Hey everyone, welcome back to my Calc YouTube channel, where I will be covering tutoring videos for math. In this case, it will be both Calc AB and BC. So the second topic that I'll be covering is limits. This video will be continuing off from the previous video of continuity. So if you haven't already, please watch that. So to begin with, what is a limit? A limit is just a value that a function approaches as your input, which will be x, approaches another value. And here you have your notation. So the basic idea is as x approaches a, f of x approaches b, or L, or just anything that signifies some real number. And so here's your notation. The limit of f of x as x approaches a is equal to your value. And then you have a few types of limits. One is just a regular limit, where you don't need to factor anything out. Take the function y or f of x is equal to x squared plus 1. If you were to find the limit of this function as x approaches 1, you could just put f of 1, right? Since this function is always continuous and there's no need to actually factor anything out. If a function is continuous at the point which you're trying to find a limit, what you could do is just plug that point into the function, and then you get an easy value. So in this case, that would be 2. But if you were to take a function like x squared minus 1 over x plus 1 and find that same limit, so instead of 1, we'll do negative 1, since that would cause an asymptote. You would end up getting 0 over 0, which is an indeterminate form, meaning that you can't calculate the limit. Or can you? You actually can calculate this limit, because x squared 1 can just be written as x plus 1 over x minus 1, and then you have x plus 1 on the denominator. And then don't forget the limit line on each line, just because you haven't evaluated it yet. So now you can cancel out this x plus 1 on both the numerator and denominator. So you have the limit of x minus 1 as x approaches negative 1, which is equivalent to the original function. And then so you just get minus 1 minus 1, which gives you negative 2. So you'll have multiple other questions like that, where you might think you get an indeterminate form, but you don't actually get an indeterminate form, and it's just a matter of factoring out certain things. And you'll also get questions with log principles, and that can be rearranged very easily to actually find out the limit instead of making it much more difficult. Take the limit of log base 8 x plus 10 as x approaches 502. This seems pretty easy, since you can just substitute 502 plus 10, giving you 512, and this just evaluates to a nice round number 3. But if you were to have more functions inside the log limit, say it was x plus 2 times x minus 9 times x plus 3 squared, you can just rearrange that so that you have log x plus 2 plus log x plus 3, x minus 9 plus 2 log x plus 3. And I say 2 log because the square can be taken out. And if you've done any previous math course, you may be familiar with how the logarithmic rules work. As long as they're the same base and you're multiplying or dividing, you can rearrange it so that it's either added or subtracted like this. But that's for another video when I begin making tutorials for other math courses. But besides these type of limits, there is also the end behavior, which is not too different to a normal limit, except for the fact that a is equal to plus or minus infinity. So you're just trying to find the infinite limit. So the limit of f of x as x approaches either infinity or negative infinity. Let's take a case study. We'll try y is f of x is equal to e to the power of x. Pardon the drawing. So as x keeps increasing, or as it goes further towards the right, y will keep increasing at an increasing rate. And it doesn't seem to be approaching any value, just gets larger and larger. So the limit of this function e to the x as x approaches infinity just happens to be infinity. But if you were to look the opposite way, so as you go to negative infinity or the further left you go, this value just keeps getting smaller, but not negative. It's always above the y-axis. So the smaller it gets, the closer to the line y equals 0 that e of x gets. And since it keeps getting closer to 0, the limit of e of x as x approaches negative infinity is also equal to 0. And so I will display some common end behaviors of functions at the end. And there are different end behaviors for different functions. Like polynomials will always be either infinity or negative infinity, depending on what the leading coefficient is and whether the degree of this polynomial is odd or even. Log functions have either approach infinity or negative infinity, but the end behavior is not as x approaches infinity or negative infinity, since log functions are only defined from 0 to infinity by default, not including 0. And trig functions don't have end behaviors because they keep oscillating. These are just a few examples. But now to seeing whether a limit exists. So for a limit to exist, you need to check both the limit from the left-hand side and the limit from the right-hand side. If they both match each other, then the limit exists. So let's take a sample function with a sample value for a. So in this function, as you get closer to a from the left-hand side, it approaches this value over here. While if you were to get closer to a from the right-hand side, it approaches the same value. So the positive limit here and the negative limit here are equal. So therefore, the limit of f of a as x approaches of f of x as x approaches a exists. But since the function here is not defined on f of a, it doesn't exist. It's not continuous. The limit can exist, but if the function is not defined at that certain point, it cannot be continuous there. So now if you were to look at a jump discontinuity, which was covered in the last video. A jump discontinuity is a discontinuity where a function will stop at a certain point and then just pick up from a completely different point and resume. So in this case, take this value to be 2 and this one to be -2 and this x value to be 1. So if you were to find the limit of f of x as x approaches 1, you need to look at the left hand side limit and the right hand side limit. So to find the left hand side limit, I would put a minus over here because that means it's starting from -infinity and going this way. If you start from the left and move your way to x equals 1, you get a value of 2. But if you to do the same thing from the right hand side, and instead of a minus you put a plus because you start from infinity, and you were to find the limit of f of x from the right, you get -2. Since both of these are not equal, the limit does not exist. And if the limit does not exist, they can definitely not be continuous. So that explains the jump discontinuities that were covered in the previous video. And then there are a few common limits that are used in calculus that you should probably remember, and those are both for trig functions. So the limit of sine x over x as x approaches 0 is somehow equal to 1, while the limit of 1 minus cosine x over x as x approaches to 0 is equal to 0. These two will be proved in these two can be proved once we do derivatives, which is a later unit in calculus. Thank you for watching this video and stay tuned for the next one.